Look up and you'll see a universe overflowing with energy. Trillions of raging furnaces pump out heat and light, making everything from swirling galaxies to our own beating hearts possible. But all of this warmth is a brief exception to the rule. Physics shows that our cosmos is slowly, irreversibly shutting down. We are crawling toward a total energy collapse known as the Big Freeze. To see exactly what that means, we have to travel trillions of years into the future and watch the four pillars of reality: light, matter, gravity, and time get systematically dismantled. Witnessing the silent final state of the cosmos provides the only scale capable of measuring the specific conditions we live in right now. Fast forward roughly 100 trillion years. At this point, the universe runs out of fuel. The very last red dwarf star flickers out. With the gas clouds exhausted, no new stars will ever ignite. The universe permanently goes dark. Earth, the sun, and all the other planets become frozen chunks of rock, drifting aimlessly through the void. Astrophysicists call this the degenerate era, a massive span of time defined entirely by the total absence of light. In this pitch-black expanse, black holes are the only active entities left. They swallow the remaining wandering debris and dominate the cosmos. The loss of light turns an active theater of creation into an infinite, cold graveyard ruled strictly by gravity. Push the timeline even further, and we find that even the physical objects we think of as immortal cannot survive entropy. Physicists predict that eventually protons, the core building blocks of all matter, will vibrate and fracture apart. Your cars, diamonds, and even the atoms inside human bodies will slowly break down and dissolve into nothingness. Without protons to provide structure, the physical universe disappears, leaving matter as a fleeting occurrence in a much longer timeline. Skip forward 10 to the power of 100 years. At this staggering distance in time, even the mighty black holes face their own mortality. The framework for understanding this endgame began with Albert Einstein, whose math gave us the rules for how gravity warps the universe. But it was Stephen Hawking who proved that black holes slowly leak radiation over billions of eons until they eventually evaporate entirely. The very last event in the cosmos is the final black hole vanishing in a massive, bright explosion. Temperature plunges to absolute zero, minus 460 degrees. All energy is spent. Surviving particles stop moving completely. With zero movement and zero energy, absolutely nothing changes. Without change, there is nothing left to measure. Time itself ceases to exist. The final result is total erasure. The universe remains permanently locked in a quiet, unchangeable stasis. That infinite, freezing darkness is the stark reality. When you look at the vast expanse of time, that void is the default state of the cosmos. Knowing that the universe will spend almost all of its existence in this condition alters how we see the world outside our windows. Compared to the trillions of years of darkness ahead, our vibrant world exists within a brief flash of probability. We occupy a specific intersection on the timeline where temperatures allow for liquid water and stars still produce enough energy to sustain biology. So next time you look up at the night sky, take a second to appreciate how much activity we get to witness. Does the ultimate end of the universe scare you, or do you find beauty in the temporary? Let me know in the comments below.